Welcome to VCF Automation 9 video series. My name is Mahar Al-Asfar and I am a product marketing engineer within the VMware Cloud Foundation division at Broadcom. This is part 5, Kubernetes cluster self-service consumption of this video series. We will start first by touching on the VCF 9 infrastructure setup and the organization tenant design that we've implemented so far. Now that we have access to the infrastructure core services, such as the vSphere Kubernetes Service, after configuring our organization, as we have seen in the previous videos, we will move on to demo how to provision a basic Kubernetes cluster using the vSphere Kubernetes Service. And then we'll move on to demo provisioning a Kubernetes cluster using the advanced options that is available to us. So let's get started and dive right in. If you watched the previous videos of this series, you should now be very familiar with our lab setup and the organization design that we have implemented so far. If not, I would encourage you to watch one of the previous videos in this series first, if you haven't already, before moving on. For this demo, I'm already logged into the VCF Automation organization portal as the organization administrator. You also could be connected here as the project advanced user. Once you log in, we land on the welcome page and we can see the projects and the namespaces we have access to based on our project membership. We also see the services widget, which is now populated with all the services we need. On the top right corner of the widget, we can see the namespace selector where we can select our destination in terms of where we want to provision our infrastructure. We will stick for now with Acme development as our destination. Now, to interact with the Kubernetes service, we can either go to the service directly by clicking on Kubernetes or click on the services overview, which takes us to the summary page of the Acme dev namespace. Here we also have a namespace selector and we can see the core stack being the project that owns both these namespaces. Again, we will stick with the Acme development for our demo here. The summary page includes important information like what region this namespace exists in, what's the status of the namespace, who is this names for in terms of what project, what zones does it cover, which VPC does it use, and some of the CPU memory limitation in terms of the resources available within the namespace. More importantly, we have access to the service styles. This is where we can go to the Kubernetes service style and see how many Kubernetes clusters so far been created by our projects. And to interact with the service, we can go and click on Go to Service or click on the Create Cluster to go directly to the cluster workflow. Clicking Go to Service takes us to the Kubernetes service. Under Services, here we can see all the different clusters that was provisioned already. We can see there's already an existing cluster that has been up for 57 days. And if we want to create new clusters, we can simply click on Create, and that takes us to the new Kubernetes cluster workflow. Here we can select from two different configuration type. For the first demo, we're going to stick with the predefined default configuration. And you can see here, the minute we got into the workflow, our Kubernetes resource YAML got generated with all the default settings. If we go next and on the review and confirm, we can look at the cluster that will be deployed with the following configuration. As you can see, the cluster name has been generated for us. We are using the latest Kubernetes release available on this environment. And in terms of the control plane, replicas and node pools and the worker nodes, they are set to 1. And we are using the smallest VM class that we can use and the default storage class available within the namespace. Now, before we can finish, remember, we always have the option to click and download the YAML file or copy the content to a clipboard, so we can save this in a source control repo like GitHub or GitLab, so it can be used with continuous deployment tools like, for example, Argo CD, or maybe create this cluster from the unified VCF CLI or modify the YAML to create newer clusters in the future. So for now, we have everything we need and we're going to go ahead and click on Finish to provision this cluster. On the top, we can see the label that the cluster is being created. Once we see the cluster showing up in the table, we can see that it has a not ready state. So for now, we need to wait until the control plane and the worker nodes are provisioned on our supervisor within the Acme development namespace. Just to see what's happening behind the scene, we can switch to the vCenter, and we can see that in the Acme development namespace on the management domain, we've already been deploying a OVF template to provision the control plane. We can see there's a resource pool that got created for the cluster, which will include both the control VM and the worker node within this. So we're going to give this time for it to boot and get assigned IP address and put on the right network, and we'll come back once it's up and running. It looks like our nodes have been provisioned and booted. We can see the two nodes that got provisioned for the cluster, one being the worker node and one being the control plane. And on the control plane, you can see it was assigned an IP, and it's configured with 2 CPUs and 2 GB of memory. This is based on the VM class that was used, which was best effort extra small. And also it has been connected to a private subnet set called by the same name as the Kubernetes cluster, so it is easily identifiable. So if we go and switch to the VCF Automation again, we can see that the cluster has a ready status. It's using the latest version of the Kubernetes based on the environment, and it's been up for 5 minutes. Clicking the double arrow takes us to some options here where we can see things like labels and information on the control plane and the node pool, and access to the active YAML. So this is the YAML that the cluster is using as its active configuration, and you can see all the status at the bottom here. So this is editable, so you can edit this YAML and be able to update, for example, the version of the cluster. So it kicks off and triggers a rolling update and updates the cluster, let's say, to the next version that you want to upgrade to, if one is available, of course. The other thing is that we have a kube config file here. Now we will see later in the video series other ways to access the VKS cluster once it's provisioned, but the quickest way to interact with the cluster right now is to be able to download the kube config file, which we will download and we'll upload to our terminal, and we'll use it with the kubectl command line to do some operations on the Kubernetes cluster that we just provisioned. Now, clicking on the Kubernetes cluster takes us to the summary cluster details. So here we can do some day 2 actions, like attaching needed volumes, for example, on the cluster level, or look at some information like, for example, the certification, if it's enabled, and what's the rotation and number of days. So every 90 days is going to rotate automatically the certificate. The networking configuration of the VKS cluster, so we can see it's using Antria as the container network interface. It's using this subnet with this CIDR for the pods. Anytime we provision pods on the VKS cluster, it's going to use this subnet and this CIDR. And for when we create services, it's going to use a different subnet. And then we have the service domain, which is set to cluster.local. All these things with the default configurations is things that you cannot edit when you're configuring your Kubernetes cluster. But we will see how we can override some of those settings later when we actually use the custom configuration. On the control plane and the node pools here, we can actually edit the control plane or the node pools for the worker nodes, and we can scale in and out by increasing the replicas of the number of control plane VMs, or scale up or down, changing the VM class to a bigger VM class that's available to us. So here I can go from extra small to small, medium, or large, completely and without disruption. We can also add volumes only on the control plane or add volumes only on the worker nodes. At the bottom of the page, we can see the cluster health status and also look at some of the events that the cluster went through. So if we scroll up and go back to our list of clusters, now we have 2 clusters. So let's switch to our terminal real quickly, and we've already uploaded the kubeconfig file to our folder, and we can easily now paste a kubectl command, for example, to get the namespaces, and pass in the kubeconfig file that we downloaded with the -- kubeconfig parameters. Of course, the assumption here is you already have kubectl deployed as a package on your, let's say, Linux terminal. If we click, we can see we can interact with the cluster and list all the namespaces running currently on the cluster. And if we do the same thing to, for example, look at the, to get the number of nodes or get the nodes of the cluster, we can see we have 2 nodes, one being the control plane and one being the worker node. Now let's look at the custom configuration when we're creating a VKS cluster. Again, we click on create to create our Kubernetes cluster, but this time when it comes to the configuration type, we're going to click and select the custom configuration. And automatically you can see that the generated Kubernetes resource YAML was reset back to just a few lines, which just includes the name of the Kubernetes cluster, which we will modify momentarily, and the namespace it's being provisioned in. Once we click next, the first section is all the different general settings where we can define things like storage and networking settings for this cluster. So starting with the cluster name, we're going to give this a name at the end to reflect that this is the advanced or custom configuration. And then we move on to select the cluster class. Now the cluster class here is selected 3.3.0, which is the most recent cluster class. This is the API-based template that is used for managing the life cycle of this Kubernetes cluster. So this is what allows us to actually be able to define some of the configuration that we're seeing in the UI or some of the configuration that we use within the Kubernetes resource YAML. Moving on to the Kubernetes releases, here we can select from a number of supported Kubernetes releases. This is again based on the vSphere Kubernetes cluster service version that you're running within your environment. So we're gonna, for this demonstration, we're not gonna go with the latest. We're gonna go with the standard, for example, in our organization, which is version 1.30.8, and then move on to a section where we can set things like labels, taints, and volumes, and storage classes. In this step here, this will apply to all the control plane and node pools unless they were overridden by subsequent steps. So what this means here is that anything that we do here is going to apply to all the nodes of the cluster, whether they're the control plane or nodes or the worker nodes. So labels, taints to control where your pods is scheduled, creating volumes if additional storage is needed, and then the certificate rotation, which you can disable or enable. If it's enabled, you can maybe define a longer period of time for the certificate rotation. So here we select 6 months and move on to the cluster FQDN, which is optional. So you can pass any domain for your fully qualified domain name and your NTP server. And then the trust optional here, this is a system-wide certificate trust for all the nodes. If you want your VKS cluster to trust specific certificates ahead of time, this is our opportunity here. We can either use a secret ref from a secret store or use the content to add the certificate content here, and you can add multiple certificate that you can trust at the same time. So here we're gonna, this is optional, so we're gonna leave it empty and move on to the next section where we can set up our proxy. So if you need internet access via a proxy, whether it's HTTP or HTTPS, including the option to include no proxy for certain domains, like let's say internal domains, you can specify them here. And this is the network section where we have the ability or opportunity to put our own CIDRs for what we want the pods to use when they're provisioned, CIDRs for the services when they get created, and the service domain that we want to use. And this could be something like your organizational fully qualified domain name that you work with. On the persistent volume storage, these are labeled as optional. By default, all storage classes available within the namespace will be inherited by the VKS cluster. But if you have multiple storage classes and you only want specific ones, you have the option to go and select the storage class that you want, and you can add multiple here. and select which one out of those is the default storage class is going to be labeled on the VKS cluster. So this is an extra control available to you if you want to set your default storage class and the storage classes that you want your VKS cluster to have access to. Again, these are only the storage classes available within the Acme development namespace. Heading next, that'll take us to the control plane. This is where we define the topology of the cluster controllers. So for example, how many replicas we need, what is the size of the control plane VM. We'll stick with extra small for now, which going to configure the control VM with 2 virtual CPUs and 2 GB of memory. And we don't have reservation for CPU or memory. And then we move to the storage class in terms of where and what's backend storage we want this control plane VM to be hosted on, and which OS image do we want to use. By default, Photon is selected, but you can also select Ubuntu as the OS image for the control plane VM. The volume here is optional, and this is going to override the volumes that we saw initially at the beginning of the workflow, which was at a cluster level. So if you've defined anything on the cluster level and then you went down and configured different volumes, this will override the cluster level volumes. This is assuming that you want to add additional storage that might be different on the control plane VM than the worker nodes, for example. After that, we have the node pool. Then the node pool is really a group of worker nodes sharing the same resources, allocation, and storage. You can create multiple node pools. Every node pool may be dedicated for a specific application, for example, but you at least need to add one at a minimum. Again, here we have the number of replica in terms of how many worker nodes we need. We see our zone automatically been selected because the worker nodes within a node pool has to be on the same zone and not across, unlike the control plane VM where they can be stretched across one or more zone depending on how the supervisor is configured. And then we have things like the size of the node pool, the storage class, the backend storage, the OS image, very similar options that similar to the control plane VM that we just saw. In addition to if you want to define and configure labels and taints or configure additional volume. We'll leave everything as default here and click next and click finish. This will create our node pool and we'll update our Kubernetes resource YAML. As you can see on line 39, we have a section for worker nodes and has some of the options that we've selected. Next comes the step where we can review our configuration and the YAML generated. Again, we can download the YAML based on our inputs to a zip file or copy it to the clipboard so we can use it with continuous deployment tools like Argo CD, maybe put it on GitHub or GitLab as the source control repos, or deploy the YAML from the unified VCF command line to deploy this cluster, or change the YAML to deploy different clusters. Once we're ready, we're going to hit finish. And from here, it's pretty much the same experience as we saw when we provisioned the first cluster using the default configuration. Now, before I end this video, there's a few things that I just want to touch on quickly, and that is the networking for this Kubernetes cluster. If we go to the network service, you'll see that for every cluster we provisioned, a load balancer that got created resulted in the service that we see in front of us here. So the first service is for the Kubernetes Cluster Advanced that we just created. This is the cluster IP, and this is the external IP that we can use from our command line to interact with the cluster on port 6443. The reason we need a load balancer is that because if we go to the VPC within the Acme development namespace and click on our default VPC and click on our subnet sets, you can see that every Kubernetes cluster that gets created creates a private subnet set for the cluster that continue to exist as long as the cluster exists. So if you delete the cluster, it will remove this subnet set, and within the subnet set, we have the IP assignment set to automatic, and the size in terms of the number of IP it's using is 32. If we click into the subnet, we can see that when it was created and if it's ready or not and how long it's been up for. This concludes part 5 of the VCF Automation 9 video series. Hope you enjoyed it. Thank you for watching and see you in the next one.